Okay, we're going to study a little bit about quadrilaterals and parallelograms in this section. So first of all, quadrilateral means four sides, a four-sided figure. Okay, and then what makes a quadrilateral a parallelogram? If both pairs of opposite sides are parallel. So both pairs of opposite sides are parallel. So which one of these is not a parallelogram? Well, let's see. Must be this one right here. Trapezoid. These two are parallel, but these two are not. Those two aren't parallel. Okay. So define a parallelogram. Basically what we have up there when we said what makes a quadrilateral parallelogram. Parallelogram. Both pairs of opposite sides are parallel. Okay, wrote that all out. Okay. So here we go. If a quadrilateral is a parallelogram, then its opposite sides are parallel. If a quadrilateral is a parallelogram, then the opposite sides are also congruent. If they're parallel, then they turn out to be congruent. And then, let's see, given the following are parallelograms, if I know that they're parallelograms, then I know 4x plus 5 equals x plus 14. Remember, opposite sides are congruent and parallel. So we end up with 3x equals 9, so x equals 3. On this side right here, this is given as a parallelogram, so I know this side is congruent to this side, so a negative 2x squared minus 11x is going to equal 5. Well, this is quadratic, remember, and if it's quadratic, we're going to either factor it or put in the quadratic formula to figure out what x is. So I think I'm going to try factoring it first. And remember, I always like to factor with a positive leading coefficient. So I'm going to move the 2x squared and the 11x to the other side. I'm going to move them over this way. So my new equation is going to look like 2x squared plus 11x plus 5 equals 0. And now I'm going to go ahead and factor that. I think that'll factor. I'm going to use 2 and 1 for my factor pairs of 2, and I'm going to do 1 and 5. Oops, so I'm going to put x here, and I'm going to put 5 here, 1 here, positive and a positive. So let's do a quick check. 1x, 10x, so yep, 11x in the middle, very good. So it looks like to me then x equals a negative a half, or x equals negative 5. Okay, let's just do a quick check to make sure that those both answers are okay to use. I mean, we can have a negative x, but when we plug it back in, it can't give us a negative side. So I'm going to do the negative 1/2 first. So I'm going to go negative 2, and then I'm going to go a negative a half squared minus 11 times a negative 1/2. And that gives me a positive 5, and 5 equals 5, so that answer is okay. And then let's try negative 5. So we're going to go negative 2, and then we're going to go negative 5 squared minus 11 times negative 5, and that gives me positive 5 also, so both those answers work. So both of those are good answers for x. Oh, whoops, did I not answer the... Can x equal a negative number? Yes, it can. It's just that we can't have a negative side once we put it back in. Okay, so in a parallelogram, if the lines are parallel, then we have all of these angle relationships which are true. So angle A and angle B. If we look over here, angle A and angle B, if you remember from parallel lines, so here's angle A, here's angle B. If you think of this as the transversal, and these two are parallel lines, these were called consecutive interior angles. So those were called consecutive interior. And I don't know if you remember the theorem on that one, but consecutive interior angles add up to 180. So they're supplementary. So those are supplementary. Okay, let's look at angle B and C. So I feel like we could do the same thing with angle B and C. Come back over here and I say, well, here's angle B and here's angle C. This is my transversal. These two are my parallel lines. So those are also consecutive interior angles. So angle B and C are same thing, consecutive interior angles, they're supplementary. Okay, what about C and D? I feel like we could do the same thing with C and D. I feel like all of these are going to be, let's just make sure. C and D, that's C and D. Those are consecutive interior. And the last one is A and D. So here's A, here's D, consecutive interior. They're all consecutive interior angles. So they're all supplementary. So if I tell you angle A is 100, so let's come over here and put 100, then that would mean that angle B would have to be 80 because they are consecutive interior. Same thing with A and D, that would have to be 80 because those two are supplementary. Then that means this one is, angle C is 100. Okay? All right. If a quadrilateral is a parallelogram, then the consecutive angles are supplementary. We just went and did all of that on that slide. And if you noticed from over here, not only are they supplementary, but the opposite angles are congruent. So we have consecutive angles, supplementary, and then down here, new theorem, opposite angles are congruent, and that's what's marked here. These two are congruent, and these two are congruent. All right. So keeping track of all those properties, let's see what we can figure out. It says use the properties of a parallelogram. Now I know it's a parallelogram to find x and then the measure of angle F. So when we're done, we need to find angle F. Well, this one's easy. I know that opposite angles are congruent in a parallelogram. So that one's 68. Over here on the right, I know that consecutive angles are supplementary. So I know that 3x plus 13 plus 5x minus 9, that's going to equal 180 degrees. They're supplementary. So combine our like terms. So 8x plus 4 equals 180. Subtract our 4. So 8x equals 176. And then divide that by 8. So let's see. 176 divided by 8 is 22. Oh, let's see. So, and then we need to figure out what angle F is when we're done. So 3 times 22 plus 13 is 79 degrees. So angle F is 79 degrees. Okay, down here at the bottom. Once again, E and F, those are considered consecutive, so that means they add to 180. So 55 plus 12x plus 5 equals 180. And now we'll combine our like terms. So 12x plus 60 equals 180. Let's move the 60 to the other side. So subtract 60. So 12x equals 120. So x equals 10. So let's plug 10 back in here, and we're going to have 12 times 10 plus 5, and that means angle x is 125 degrees. And then over here, angle F, since these are opposite angles, angle F has to be 65 degrees, so then that would mean then that x would have to be 50. 50 plus 15 is 65. Okay. Last idea, if a quadrilateral is a parallelogram, then the diagonals bisect each other. So in this picture down here at the bottom, I'm telling you that it's a parallelogram. So when you see this symbol right here, when they draw a parallelogram, they're telling you it's a parallelogram. So all the properties are true. It says find x and y. Okay, so if it's a parallelogram, then this angle right here, 30 degrees, is an alternating interior angle of that one. So that must mean then that x is 30 degrees. And one of the properties of a parallelogram is the diagonals bisect each other. So if this side right here is 2, then this side must be 2. So y equals 2. Okay, given that you have parallelogram ABCD, find K and M. All right, well, let's see. We know that the diagonals bisect each other in a parallelogram, so M must equal 8. And then K must be 7. 7 plus 4 is 11. Remember, diagonals bisect each other. Okay, so what are the 5 properties that you need to know for a parallelogram? Well, first one is opposite sides are parallel. I'll use parallel. Okay, then we also know that opposite sides are congruent. And then we also know that opposite angles are congruent. And we know that the consecutive angles are supplementary. That means they add to 180, right? Supplementary. So they add. And then the last thing, the last property of a parallelogram is that the diagonals bisect each other. Okay, so you need to know those 5 properties of the parallelogram. Okay, so let's put it into action here. I'm given that parallelogram ABCD is over here to the right, and I want to find what x is. So first of all, let's figure out what information they've given me. They've told me the measure of angle ABC. So let's figure out what angle ABC is. A to B to C is this angle right here, the whole thing. And then the other angle they tell me is BCD. So I'm going to go B to C to D. That's this angle right here. Okay, those look like consecutive angles, and I know consecutive angles are supplementary, so I'm going to say 2x plus 5 plus 4x plus 7 equals 180. And then I'm going to go ahead and figure out what that's going to be, combine my like terms. So 6x plus 12 equals 180. Let's subtract the 12. And we're going to have 6x equals 168, and then divide by 6. Okay. All right, let's clear those markings off. New picture, new problem. Okay, so this one says AE. So AE is from here to here, and that's 5x plus 2. And then EC. EC is from here to here, and that's 7x minus 6. Well, I know the diagonals bisect each other, so those two must be equal. So 5x plus 2 equals 7x minus 6. Combine my like terms, and I get 2x equals 8. So x equals 4. All right, new problem. So angle ABC, so here's angle ABC, and angle A, let's see, let's draw that with a different color, angle ADC. So we're talking about this angle and this angle up here. Well, those are the angles that are congruent, so I'll just put them equal to each other and solve it. So AX minus 16 equals 4x plus 20. Combine my like terms, so 4x equals 36, and 36 divided by 4 is 9. So x equals 9. Okay, last problem. DB is 6x minus 20, so D to B is that segment. And then D to E is that segment. Okay, they are definitely not equal. I can't put them equal to each other, and they don't add up to 180 degrees, because remember, this is segments, and degrees are angles. So we can't do 180. But if you remember, the diagonal is bisected, so DE is the exact same measurement as E to B. So let's double DE and put it equal. Then they'll be equal to each other. Then those two numbers are going to be equal to each other. If I take 2DE, so 2, I'm going to double the DE, the short piece, and then that's going to equal the measurement of the long piece. And I'll solve that for x. So 4x plus 10 equals 6x minus 20. Combine my like terms, so 30 equals 2x, so x equals 15. Okay. This one says the perimeter of a parallelogram ABCD is 96 centimeters. AB is 10 centimeters less than BC. What is the length of the smaller sides? Okay, so I'm not really sure how I'm going to put my letters in, and I might not get them in the right order. So my picture may not be drawn to scale. I'm just going to start here. A, B, C, D. Okay, I know that all four sides added up is 96 because that's the perimeter. It says AB is 10 centimeters less than BC. Oh, yep, I drew that not to scale because this AB is supposed to be shorter than BC. So if it bugs you that it's not drawn to scale, then redraw your picture. I'm just going to leave it. Just going to put my variables in and go from there. So AB is 10 centimeters less than BC. So if I call BC X, then AB has to be 10 centimeters less than that. So I'm just going to call that side X minus 10. Okay, remember, opposite sides of a parallelogram are equal. So this side's X and this is X minus 10. I know the perimeter is 96. So if I add up all four sides, so that's going to be 4x minus 20. That's going to equal 96. Solve that for x. And you end up with 29. X equals 29. Okay, it says what's the length of the smaller side? Well, this side right here is 29. And this side right here is 29 minus 10, so it's 19. So remember, it wasn't drawn to scale. So our length of our smaller side is 19 centimeters. Okay, and then one last idea. How do you find the area of a parallelogram? Well, it's the base times the height. But remember, in a parallelogram, when you're talking base times height, you're talking perpendicular to each other. So this side right here, 12, that's not how tall the parallelogram is. How tall the parallelogram is from one base or one side to the other, so the perpendicular distance. So this is how tall it is right here, 9. So this is my height, 9. So the area is 9 times 17. And you end up with 153 meters squared. Okay, so remember, base times height, they're always perpendicular to each other. So not the 12. We don't want the 12. That's not a perpendicular height. We want the 9 times the 17. And if you could think about it, like, it's kind of it is the same formula for a rectangle, because in a parallelogram, if you took this piece right here and I cut it off and I slid it over here, you would have a rectangle. So if you take this piece right here and you cut it off, this piece right here, you cut it off and you move it to the other side, you have created a rectangle. And how do you find the area of a rectangle? Base times height. So remember, base and height always have to be perpendicular. Okay, we're done.